Welcome to the deep dive. For the longest time, the mining world is sort of operated behind these walls, right? Proprietary info, operational secrecy. But today, we're going to pull back that curtain. We want to show you why that's really ending and how this idea of radical open collaboration, it's become essential. It's driving the next big resource projects.
That's spot on. And the stuff we're drawing on today, it comes straight from the floor at the CIM Connect convention. Real conversations, with people from Glencore Technology, Hudbay Minerals, Agnico Eagle.
So real-world insights.
Exactly. It's kind of a blueprint for how the industry is changing. We're really focusing on the tech shifts, things like the Albion process, the Jameson cell, and importantly, what these mean for, well, the huge ESG implications, especially for Hudbay's Copper World project over in the U.S.
Okay, let's get into that. This new way of working, this paradigm, it starts with a mindset shift. And Glencore Technology, or GT, they really illustrate this well.
Right. Scott Martin, he's their sales director for the Americas, was talking about this. They're based in Brisbane, sure, but they're global.
Yeah.
Offices in Santiago, Moscow, Johannesburg. But the key thing he mentioned, they recently started operating, quote, out on their own. So they moved out from under Glencore's copper division. They're standing alone now as a tech provider.
Interesting. So more independent.
Yeah. And what's really fascinating is how they're changing the language, the vocabulary they use. Scott emphasized they prefer the word collaboration way over client.
Collaboration, not client. Okay.
Exactly. The idea is their partner's success is their success. It's about total transparency. Moving away from those old silos that kept everyone separate, the end users, the engineers, the EPCMs.
Right, the EPCM, the engineering, procurement, construction managers, they were always kind of in their own box.
Totally. And those silos just slowed everything down. Information didn't flow. GT's approach is basically share everything openly. The tech results are better, sure, but crucially, the plant commissioning, the ramp-up, which costs billions, happens faster.
That makes sense. Get everyone talking early.
And they have proof it works. Hudbay's New Britannia installation that was commissioned several years back using this transparent model. Really successful.
Ah, okay. So there's a track record.
Definitely. And now they're taking that same collaborative model and applying it maybe even more intensely to the Copper World project.
Now, you mentioned Hudbay. We should probably introduce Chris Marion. He's Hudbay's manager of metallurgy.
Yeah, Chris has been with Hudbay about 5 years now. He came in after his PhD at McGill, really focused on process development, innovation.
So bringing fresh ideas.
Exactly. And he's been working super closely with Scott Martin from GT, kind of shows how the next generation really wants this openness.
Okay, so let's zoom in on the big one. Hudbay's Copper World project.
Yeah.
In the U.S., you mentioned 3 core GT technologies being used there.
That's right. So first, you've got the ice mill. That's for fine grinding. Second, the Jameson cell. That's a flotation technology. And third, this really interesting side process, the Albion process, which actually wasn't even in the original plan.
Before we hit Albion, why are those first 2, Isomil and Jameson cell, so important for Copper World specifically?
Good question. The Isomil is vital because the ore there, it needs ultra-fine grinding, like really fine to get the metals out. It's a complex ore body.
Right.
Then the Jameson cell, the big deal there is its design. It's vertical. It uses buoyancy differently. And the result is it dramatically shrinks the physical footprint of the plant compared to traditional, horizontal flotation cells.
Less space needed on site. That's always a win.
Always. Especially when you're building something complex from scratch.
Okay, so that brings us to the Albion process. You said it wasn't initially planned.
Right. Hudbay had to do a lot of trade-off studies. They were comparing different hydromet processes like Albion against the old standard pyrosmelting.
You mean traditional smelting, high temperatures, furnaces?
Exactly that. And here's where it gets really interesting. Albion won out. The economics looked good, sure. But the primary driver, a massive, undeniable win on the ESG front. Environment, social, governance.
Okay, ESG driving the tech choice. That feels like a major shift.
It absolutely is.
Yeah.
This is basically environmental responsibility dictating a core process choice.
So spell it out for us. What's the old way, and how does Albion change the whole carbon picture?
Okay, so traditionally, a mine like this produces copper concentrate. It's maybe, 20–30% copper?
Right. Not pure copper yet.
Not at all. So you dry it, then you ship it. Usually long distances, often across the ocean, to smelters in Asia. These are huge, energy-hungry pyrosmelters running at very high temperatures.
So you've got shipping emissions.
Huge shipping emissions.
Hmm.
Then massive energy use and more emissions at the smelter itself, far away.
Plus, I guess, risks with shipping, supply chains, all that.
Exactly. Potential geopolitical risks, too. Now, the Albion process, it just wipes all that out.
Yeah.
The absolute game changer is this. Hudbay won't ship concentrate anymore. Instead, using Albion, they'll produce high-purity copper cathode-like 99.99% pure copper metal right there at the Copper World site in the U.S.
Oh, okay.
And that cathode will then be used domestically. So you eliminate the global shipping, you eliminate the overseas smelting. The carbon footprint reduction is just enormous.
That is, yeah, that's genuinely revolutionary for a U.S. mine. Okay, technically, though, you described Albion as an oxidative leach around 90 degrees C using heat and acid.
It sounds simple enough on the surface.
Yeah, it sounds simple. The basic leach chemistry, it's relatively well understood, yes. Oxidative leach, moderate temperature, add some acid.
But there's a catch.
There's always a catch, isn't there? The real complexity, and this is the part Hudbay has to solve collaboratively, is what happens after the leach, the downstream processing.
Specifically, dealing with the leftover solid residue.
Yeah.
And also the elemental sulfur that the process creates. Managing that residue, that's very specific to this particular ore body. And finding the solution, well, that's kind of outside GT's main expertise area.
Oh, okay. So GT provides the core Albion tech, but handling the leftovers, that's a separate challenge Hudbay needs to crack.
Interestingly. And it's a big technical hurdle.
So how do you tackle that when part of the problem is outside your main tech partner's wheelhouse? This sounds like where that collaboration piece becomes absolutely critical.
Exactly. This is where that collaborative testing pathway really kicks in. Chris Marion from Hudbay, he talked about this. It was a really rigorous multi-stage process. It started about 3 years ago with intense lab work, bench scale tests, close collaboration from day one.
Okay, tiny batches first.
Right. Then, once those results looked promising enough, to justify spending more, they moved to a pilot run. A physical pilot plant set up in Brisbane at a place called Core Resources.
And this wasn't just sending samples off.
No way. Chris Marion flew over. He was physically there, representing Hudbay, working right alongside the GT people and the lab staff at Core Resources.
Wow. All in the same room.
Literally. All focused on tweaking the process, getting the best results in real time. It shows you the level of trust, the commitment to actually doing the collaboration.
It sounds like a constant feedback loop.
Totally iterative.
Yeah.
GT uses these planned milestones, points where everyone stops, looks at the results, talks openly about what's working, what's not, before taking the next step.
And it goes beyond just Albion, right? You mentioned they're still working on improvements at the existing New Britannia mine.
Yeah, Hudbay is actively working on process tweaks there, alongside GT and another group, JK Tech, also out of Brisbane. And all that learning, the operational data from New Britannia, it feeds directly back into the engineering and planning for Copper World.
So they're de-risking Copper World before they even fully break ground, using learnings from an operating mine.
Exactly. It reduces the unknowns for the big startup.
Okay, so this deep collaboration, this transparency, it's not just for massive new projects like Copper World. You mentioned a second example, Agnico Eagle.
That's right, a different scenario, working on an existing operation. We heard from Mayo Shora, she's an innovation project methodologist there, and also Hor Curry, a project methodologist. They worked with GT too.
And what was the challenge at Agnico Eagle?
This was at their Goldex mine up in Quebec. It processes both copper and gold. They needed help optimizing their sortation circuit.
Why? What changed?
They started processing ore from a new deposit back in January 2024. And this new ore, it had what they called some copper issue. Basically, the copper minerals were behaving in a way that interfered with getting the best gold recovery, and gold is the main target there.
So the copper was causing problems for the gold.
Pretty much. So the solution involved bringing in a Jameson Cell pilot rig right onto the Goldex site. This was around early spring 2024, February, March time.
And this wasn't a small test rig.
Definitely not. It was substantial. Had a feed rate of 8 cubic meters per hour. So a serious piece of kit designed for real process testing, not just lab scale stuff.
Okay, and how did they run the tests?
It was done in phases. Phase 1 was led by Mayo Shora. Interestingly, he was actually still a student when she started on this, but they've since hired her full-time. Her job was to really define the operating parameters, find the settings that gave good results for both copper and gold recovery and grade.
Get the basics right first.
Exactly. Then Hor Curry took over for phase 2. His focus was more on de-risking, taking the best conditions my found, the settings that gave the best grades and recoveries, and running longer tests
Why longer tests?
to make sure those good results were stable over time, to really optimize things and prove it would work reliably if they decided to build a full-scale version.
And the collaboration piece here. Same vibe as with Hudbay.
Very much so. Agnico was incredibly open. They shared all their results with GT, the good, the bad, the just okay. Hora mentioned working really closely with her GT contact, Rebecca Mishny, constant check-ins, leveraging her experience.
So quick questions, quick updates.
Yeah, that kind of reciprocal communication. Agnico asks a question, GT provides input based on their global experience. Agnico shares the latest data immediately. It just allows both sides to learn faster and ultimately find the best possible solution.
It speeds everything up, doesn't it? Instead of Agnico trying to solve it all internally for months or a year.
Exactly. They tap into GT's broader knowledge instantly. And GT benefits too. They get valuable real-world data on how their tech performs with a challenging ore type. It helps them improve their own equipment and understanding.
Okay, so that really lands the main point for you, the listener. This idea of collaboration, it's not just a nice to have anymore. It's actually the critical competitive advantage, especially when you're trying to implement these complex, high-impact technologies. You should now have a clearer picture, a high-level view of how these partnerships are working, using specific tech like the isomil, the Jameson cell, and especially that transformative Albion process, and how it's all reshaping project economics and, crucially, the environmental footprint of major U.S. mining like we see with Copper World.
Yeah, and if you connect it back to the bigger industry picture, this transparency, it's powerful. It seriously de-risks adopting new technology. It helps speed up actually building these massive plants because you're sharing knowledge, not hoarding it in those old silos that just cause delays.
Right, it avoids reinventing the wheel inside every company.
Exactly. In an industry where capital costs are enormous, that speed and shared learning is invaluable.
Okay, so let's leave you with a final thought to chew on. We've talked a lot about the Albion process and how its trickiest part is managing that complex residue and the elemental sulfur that comes out the other end, the downstream stuff. Now, if this new era is all about knowledge sharing being the key to success, what happens next? What kind of unforeseen operational risks or maybe even regulatory risks might pop up when major mining companies feel compelled, maybe by market pressure, to share their solutions for these really complex, often very company-specific residue challenges, especially when those solutions are tied so closely to environmental compliance?
That's a tough one. Sharing the core process is one thing, but sharing the secret sauce for handling unique waste streams, that could get complicated.
Something to think about as this push for transparency keeps changing the landscape.